What are Latin score designs? You'll typically see them used within the agriculture industry, where they're particularly useful with helping to eliminate factors such as variance in water intake or soil fertility among different locations in a field of crops. Small variances such as a stream or insect colony next to a section of a field can affect the analysis of the field's yield, so a Latin score design can be used to eliminate those variances. To put it simply, they're used to control variation within experiments. They allow for two blocking factors, each of which can control variation in two different directions. Rows and columns are used as two variables, where each treatment occurs exactly once in each row and column, similarly to Sudoku. Although they are typically used in agriculture, they can also be applied to a variety of applications. A quick example would be if a company wanted to test the efficiency of a new solar panel design they've created. The experiment will always begin with a randomly assigned treatment, and for this example, each day within the columns represents Monday through Friday, while each trial within the rows represent how many times per day each panel is tested. The initial wattage output will be collected and placed in a table similar to this. To begin analyzing the results, the mean or average of all the values within the table has to be calculated to find the overall average output, which for this example is approximately 1014 watts. The next step is to find the block effects, which can be done by subtracting the overall average from each row's average. We then need to find the new design effects, which is done by subtracting the overall average from each column's average. Finally, to find the residuals or outliers, we'll end up taking each individual data point collected from the first table, minus the row average, minus the column average, plus the overall average. The values that are the most extreme, either positively or negatively, are outliers, so those particular treatments should be analyzed for any meaningful variations to determine any possible improvements for future designs. Essentially, Latin score designs are used to control or remove factors from an experiment or procedure that would otherwise alter the analysis of the data. Small nuisance factors such as the variability of humidity or sunlight from the northern and southern ends of a field can be eliminated by this design, which in turn can result in a more accurate understanding of the cause of an experiment's variability.